Hello everyone. In this video we're going to take a look at VisualCAMc, the new plugin for Onshape. And we're going to show you how easy it is to create 2.5 axis toolpaths for a part. So we have a part displayed here in VisualCAMc, and we have the machine, the post, we have our stock defined, we have a setup, and we have a work 0. So let's go ahead and select our 2.5 axis facing operation to start with. We're going to face the top of this part off. We'll pick the select tool, and we have a facing operation, a facing tool already created. You can use any flat mill or even a ball mill for facing. Well, let's go ahead and use our facing tool. For the feeds and speeds, we'll leave those set to our default values. For the clearance plane, this is the location of the plane where the tool retracts to when it clears and needs to go to another location to start cutting. So we're going to have the plane definition set to automatic. We'll let the system determine a safe location for the plane. And for the cut transfer method, we'll set that to clearance plane. Then we'll go to the parameters section. These are the cutting parameters for the facing operation. We'll go ahead and set our tolerance. And we're going to set our stock to 0. Stock's defined in the X and the Y direction. And we're going to, for the location of the cut geometry, let's go ahead and select our geometry. And selecting machining regions is real easy in VisualCAMc. In this facing operation, we want to select the entire top perimeter. So we'll go ahead and just right click on an edge, and it'll select the chain select the perimeter for you. So the location of our cut geometry is going to be at the bottom of our cut. This means that the tool will cut down to the Z level where our geometry is selected. So for the cut direction, we'll select mixed, and for the cut type, we're going to use successive offsets of the perimeter profile. Then also our total cut depth will be 0 since we're cutting right down to the bottom of our cut geometry. And the depth of each level, obviously that'll be 0 since there's going to be no additional depth added. And our step distance, we'll go ahead and leave that set to 0.125, and this will be the offset for the facing operation. Now we'll select the entry and exit tab. Entry and exit controls how the cutter approaches and engages the part and how it departs and retracts from the part. So for the entry type, we'll go ahead and select geometric, and we'll select radial. And then for the exit, we'll also select geometric and radial as well. And we'll accept the default radius value for the entry and the exit. Let's generate the toolpath. So as you can see, we have a facing operation located at the level of our cut geometry. And here's our entry motion and our radial engagement. And here is our offset cut pattern. And here is our radial exit and retract. Now that we have our facing operation defined, we can go ahead and create our profiling operation to cut the perimeter. So we'll go to 2.5 axis, pick profiling. The profiling dialog displays at the top. For the name of the profiling operation, we'll just leave it as profiling. For the tool, we'll go ahead and select our flat mill 1/8 inch tool. For the feeds and speeds, we'll leave those set to the default values. Clearance plane, we'll leave those set to the default values. Now for parameters for profiling, we'll leave the tolerance set to 1/1000. Stock will be 0. This means we're going to cut right up to the sidewalls of the perimeter of the part. Our location of cut geometry, as you can see, our perimeter that we selected for our facing operation is already pre-selected, so we can leave that. And the location of the cut geometry for profiling will be at the top. And we're going to have a cut direction set to mixed. Our width of our cut will be 0. We're going to have one pass around the edges. and our step per cut will be set to 0. And for the total cut depth, we'll set that to 0.157. So it's going to start at our geometry that we selected at the top, and it's going to cut down 0.157 for a total cut depth. And for the depth of each level, we'll set that to 0.05. Now, this is a closed perimeter that we selected, so we'll check that box, and we'll select the outside. Now we'll go ahead and select the entry and exit tab. Now for profiling, I want to have a ramp entry motion, so we'll select a long path. For the height of the ramp, we'll set that to 0.15. And for the angle of the ramp, we'll set that to 5 degrees. So we're going to have a nice approach and ramp entry motion. Now for the exit, we'll go ahead and leave that set to geometric, and we'll have that as a radial exit. And we'll go ahead and pick generate. So here is our profiling operation. As you can see, we have a nice 5-degree ramp entry motion that wraps around the part to our start point over here. And we have 1, 2, 3, 4 levels that was required to get down to the 1.57 depth. And over here we have our radial retract and departure motion over here. So now that we have a facing operation and we have a profiling operation, let's go ahead and select the drilling operation to drill some of these holes. We'll go up to the top here and select drill, and for the tool we'll go ahead and select 0.157 diameter drill. For the feeds and speeds, we'll go ahead and slow this down since we're doing a drilling operation. And for the clearance plane, we'll leave that to the default value of clearance plane. Now for our drilling parameters, our drill depth, let's go ahead and select our geometry first. We're going to machine these 4 holes inside. Those are 0.157 diameter holes. So our drill depth is going to be 0.157 deep, because that's the thickness of our part. We're going to check this box to add the tooltip to the drill depth, so it'll extend the drill past the bottom of the part by the tip of the tool. For dwell, we'll set that to time. We'll leave that set to 5 seconds. And for the approach distance, we'll set that to 0.2. So this is going to approach 0.2 above the part, and then it will start our drill motion and drill the holes out all the way through. So let's go ahead and generate the tool path. So you can see we have a drilling operation here, and if you look at the bottom, you'll see that it extends past the bottom of the part to clear the tooltip of the drill tool. Well, that's it for a quick walkthrough of 2.5 axis toolpaths in VisualCAMc for Onshape.